So last week, I made the following comment on the Flat Earth Debate Discord server. I've never seen 10th Man demonstrate anything using real sextant angles. I've never seen him do an actual cell nav fix. I would pay money to see that. No joke. I'll super chat if 10th ever turns altitude angles into lat-long coordinates. Now, perhaps that came off a bit snarky, but I'm being sincere here. I actually respect 10th's enthusiasm for celestial navigation, and really want to see him take the exciting next step of actually doing a position fix. Sadly, that doesn't seem to be the direction things are heading. Because through Divergent Droid, 10th Man replied, ultimately saying, he needs to debunk our cited sources. Celestial navigation is what he is against, not our reading in context of these sources. Now, recall that my original comment had nothing to do with his citations, or overall narrative around sextants, or even the shape of the Earth. I was just noting that I had never seen him actually demonstrate a celestial navigation position fix, something I think we all agree would be very cool if he did. Maybe I've missed that video, in which case maybe someone could post the link and I'll follow through with that congratulatory super chat. But honestly, I think if that video existed, he would have responded with that instead of diverting to talk of citations. But citations is where he went. And now Divergent Droid has decided I must convince 10th Man he is wrong about his citations, or be banned from the server. His reasoning seems to be that I somehow misrepresented things when I noted that I had never seen 10th do any actual celestial navigation. But hey, enough prologue, let's talk about his citations and the context we find them in. Because, 10th, in actuality, all of your sources agree with me and not you. You just strip away any context that contradicts you, ignoring or outright denying huge swaths of your own sources, allowing you to misrepresent what they say. For example, you cite Harold Jacobi's navigation, reading from this page that describes sextant altitude angles and the zenith angle. You try to use it to support your claim that altitude angles require a flat Earth, even though it says no such thing. Indeed, you need only go forward a few more pages to find where it explicitly shows the opposite. Here, it describes and depicts how you adjust for the dip of the horizon, correcting the lower line of your angle to horizontal. It shows how the dip is due to the curvature of the Earth's surface. Neither your sextant sight line nor the horizontal you correct to are the surface. There is no right angle triangle depicted. Indeed, you can clearly see there is only a right angle, not triangle, that is bisected by the sight line to a celestial body, splitting this right angle into the altitude and co-altitude angles, and all of that being above the curving surface of the Earth. Indeed, none of the authoritative texts you reference claim a triangle is used when getting the distance to the GP. They never assert that the lower sight line of your sextant creates a line to the GP. That is a flat Earth fallacy. That sight line is only used to indirectly establish horizontal and thus the zenith. None of your sources say the surface of the Earth is flat. They say the opposite. In Harold Jacobi's navigation, he says it as early as page 4, where he described the Earth as almost an exact sphere or round ball. Your own sources that you cite from disagree with you. The same is found when we look at other authoritative texts you cite, like Bowditch's American Practical Navigator, which I incidentally bought my first copy of back in the mid-80s at the same time I bought my first sextant. Browsing a recent copy of the APN results in all sorts of references to the Earth being globe-shaped, but nowhere does it suggest the Earth is flat. It never indicates a right triangle is used when getting the distance to the GP, nor does it say the GP is on your sextant line of sight. If you don't believe this, I welcome you providing the citation that actually states that. Not a scribbled picture of a triangle from a YouTube video, an actual textual citation in one of these authoritative texts that you cite. Maybe the evil globist conspiracy removed it from recent copies. How about we check an older copy, like one from 1880? Nope, That also describes the Earth as a globe. It also depicts altitude angles and the dip of the horizon in the same way as Jacobi, as being from a horizontal plane tangent to the curved surface of the Earth. No right triangle anywhere to be found. And notice that even 140 plus years ago, mariners understood and regularly dealt with refraction. So much for the black swan. Again, your own sources disagree with you. But what about this graphic here? Sure, the baseline clearly looks curved, not flat, and is even labeled as a great circle route, but you point out that a 90-degree zenith angle needs straight lines. So this angle indicator here means the curved line must really be straight. Checkmate, globists! Except when we actually check the source this image comes from, Air Force Manual 51-40, Volume 1, it clearly defines the zenith angle as being 90 degrees from a tangent horizontal to the curving surface of the Earth. As we've seen, that is hardly an isolated case. Honestly, this particular source you cite from doesn't do you any favors, because it refers to the globe shape or curving surface of the Earth over and over and over and over and over and over and over again. Whoa, still going. That's a lot of curving Earth references in your source there. Maybe we need to speed this up a bit. Really, guys, you claim you are just reporting on what the official documents say, but you ignore or outright deny the vast majority of it, especially any bit that contradicts your interpretation of the bits you've cherry-picked. There is a name for that. It's called confirmation bias. So, given that the rest of the document clearly indicates the Earth is globe-shaped, and that zenith and altitude angles are measured from a horizontal that is a tangent to that curved surface, is it more likely that this one cartoonish diagram is the killer flat Earth citation, or did it simply omit the horizontal tangents to make the diagram less cluttered? If only there was some way to test that. I mean, it not only goes on at length about the spherical geometry used in navigation and how elevation angles are measured from a tangent horizontal, not the surface, and dip correction is due to curvature, it also gives you a big old heaping of parallel light rays. Remember when you agreed that bubble sextants need no correction for different eye heights, giving the same altitude angle at every height? Yeah, that only works if the light is arriving parallel, as page 16 and 17 of chapter 11 describes in very exacting geometric detail. This bears repeating. When you admit that bubble sextants read the same at every eye height, you consequently agreed that light from celestial objects arrives in parallel. So once again, your own sources disagree with you. And it's not just the Air Force working against you. Remember the Quartermaster 3 and 2 Navy training courses? I think it was Brian that first presented it. You guys cherry-pick from that one, but for some reason entirely ignore all of Chapter 14, discussing celestial navigation. You know, where it lays out in exhausting detail how it uses globe-based geometry, while again never mentioning a right triangle, or the Earth being flat, or the GP being on your sextant sightline. Yet again, your sources disagree with you. Are you noticing a pattern here? Your entire argument is built on redefining elevation angles as being only possible on a flat Earth, even though the mainstream definition clearly says they are measured relative to horizontal and not the surface. You've used this to build a nonsense curved adjacent straw man that assumes the surface is a line in our angle, even though your own sources say it's not. Your desperation to prove this dependence on the Earth's surface has you ignoring navigation texts in favor of obscure websites, like from a solar panel installer running a business out of his home. But something tells me that the flat plane he is installing solar panels on is probably not the surface of the ocean. And then there's the inconvenient fact that this same website depicts the Earth as a globe on 2 other pages. So again, your own sources contradict you. But wait, you do have a source that seems to depict a right triangle. This YouTube video by Tablet Class Math, where he sketches out a rough triangle while describing the angles involved. Let's set aside for the moment that he gave an incorrect distance to the GP as 900 nautical miles, when it is easily calculated to be 2400, and he incorrectly quoted HO 229 as the nautical almanac when it's actually the site reduction tables. Because this guy is a former Navy officer, so even though he is clearly winging it and getting some stuff wrong, we should take his triangle diagram as a perfect representation of the underlying geometry, right? Well, no. As you yourself pointed out, he firmly states that the Earth is round and that actual navigation uses spherical trigonometry and not a right triangle. And while you can no doubt salve the sting of this rebuke by claiming the evil globist conspiracy must have gotten to him, this does count as yet another source that does not agree with you. But what about this one, you say? I mean, Andy Schell is an accomplished sailor, published in the prestigious Yachting World magazine, no less. And he doesn't just draw a sloppy right triangle, he comes right out and mentions it, using words. Truly, this is proof that the Earth is flat. And if you ask this guy about it, he would agree with you and not me, right? Well, it turns out Yachting World printed a follow-up article last April in which someone challenged Andy's description, saying, technically, this is incorrect. The light from the sun is arriving nearly parallel to both your observer position and the GP, and the path between you and GP is a curve over the surface of the Earth, not the flat base of a triangle. When we subtract from 90 degrees, we are not getting the complement angle to a triangle, we are getting the sun's decline from our own zenith, which we then treat as an angle drawn from the center of the Earth, not from the sun, to sweep out the partial circumference between us and the GP. And it turns out that Andy actually agrees with this. And what I really mean is he specifically agrees with me, because yes, it's me being quoted there. He replies saying, of course, that is correct, and indeed, the Earth is round. Let's take a closer look at that. Yup, your own source, the one you are citing, is specifically saying that I am correct. Andy goes on to defend his mention of a triangle as a useful trick for remembering to subtract from 90, but admits there is no triangle, saying, I found that when the folks I teach get really interested in celestial navigation, beyond a basic understanding, these mental models gradually evolve into the real concepts. Eventually, a light bulb moment will occur when a new navigator, on their own, realizes that the right angle triangle model must be wrong, because indeed the Earth is round. And then bingo, the deeper concept emerges quite naturally in the learning process. End quote. So in essence, a triangle is just a useful trick to remember to subtract from 90, but is not meant to be taken literally. And while I personally don't find that trick very useful, and even potentially confusing, which is why I don't use it when teaching my class, I do wholeheartedly agree with Andy when he says that a deeper understanding emerges as you actually dig into the process. Because there is only so much you could learn from just reading citations. Often, the full understanding of a process only emerges from actually doing the thing, and celestial navigation is very much like that. That is why I keep encouraging 10th Man and the rest of the Fed panel to actually take that next step. Otherwise, you've just trapped yourself in a loop of arguing definitions and citations. So how can we break out of this citation loop to actually test our claims? How can we explore what the real underlying geometry of celestial navigation is? Here's a crazy idea. We could actually do some. And luckily, I did just that for the college seminar I recently taught. We worked through some Meridian Passage sun sites I shot while on the Baltic Sea, and also some nautical twilight star sites I took closer to home. So buckle up, we are going to actually do this stuff for real. It starts with a sextant site of Saturn at 24 degrees, 7.0 arc minutes. Followed by Shedar at 39 degrees, 36.2 arc minutes. And finally, alter at 55 degrees, 33.8 arcminutes. Of course, we have to do the corrections on these sextant readings to get the observed altitude, and also look up the latitude-longitude coordinates of each celestial body's GP in the Nautical Almanac, based on the time we took each site. We do that first for Saturn, then Shadar, and finally Altair. And that gives us all the information we need to draw our circles of equal altitude. Now, of course, to draw the circles and have them intersect at the correct latitude-longitude coordinates, it has to be done on something the same shape as the Earth on which the angles were obtained, which is why we are doing this on a globe. If we tried to draw these circles as actual circles on a flat world map, they would fail to intersect correctly due to the distance distortions that will always result when projecting a globe to flat or vice versa. So how do we go about drawing a circle of the appropriate size on a globe? It's quite easy, actually. As you know, the distance from the observer to the GP is simply the co-altitude times 60 nautical miles per degree. This is an application of the arc length formula and gives you a curving partial circumference, a segment of a great circle route over the surface of the Earth. Since the equator is a great circle route with every degree of longitude equaling 60 nautical miles, we can use that as a scale to set the span of our drafting compass. So if we have a co-altitude of 45 degrees with a distance to the GP of 2,700 nautical miles, we can simply put one point of our drafting compass on the 0 longitude point on the equator and adjust until the other point is on 45 degrees longitude. And there you go. The only thing left is to then center the drafting compass on the latitude-longitude coordinates of the GP and draw the circle. So doing that with Altair, we size it to about 34.5 degrees. Center it on about 9 degrees north and 80.5 degrees west, and draw. Notice there is no use of the Haversine formula, no messy math of any kind. We just size the drafting compass directly to the co-altitude angle and draw. Done. We can do that because we are simply recreating the geometry of the circles of equal altitude as they are in the real world, only scaled down. Now we repeat that for Shadar. And again for Saturn. And that gives us circles intersecting right on the west side of Lake Michigan, just a bit south of 43 north latitude. And when we check that against the surveyed coordinates of this nearby landmark, we find we've hit the mark to within 1/4 of a degree, both north-south and east-west. And so there you have it, the underlying geometry of celestial navigation demonstrated on a globe. Now, of course, I'm sure some of the flat earthers out there are already raising some objections like, we don't take globes with us when sailing. But actually, in a sense, we do, because every single navigation chart and plotting sheet we use is based on the globe. It represents a zoomed-in portion of the globe's surface, reproducing the scale of longitude for that latitude, with longitude always getting closer together as you travel north and south of the equator. You don't have to take my word for that. Grab yourself some navigation charts from various latitudes and confirm it for yourself. The same is true on the open ocean, where we use plotting sheets instead of coastal charts. Take a look at that curving grid in the lower right. You strike a line across it, matching your current latitude, and it provides your longitude scale. And again, we use the same scale for both north and south latitudes. So it gets narrower as you reach larger latitude numbers both directions. exactly as you find on a globe. But those charts and plotting sheets are flat, you say. Yes, and that's where the Haversine formula comes in. You might remember we didn't use it when drawing our circles of equal altitude on a globe. Because a globe reproduces the real-world geometry, all we did was directly size our drafting compass to the co-altitude. But to put those curving lines on flat paper, we have to resort to the spherical trigonometry of site reduction. We zoom into a small portion of the globe and reduce the curved lines to straight tangents. So when refracted curvature suggested a new housekeeping question of, in the celestial sphere model, what is the transformative equation known as Haversine formula applied to? Well, here you have your answer. We only use the Haversine formula when converting the curving lines of reality to straight lines of position on flat paper. It is used to go from globe to flat, never flat to globe. So using spherical trigonometry, something that starts like this becomes something that looks like this. I do plan to make another video explaining the entire process of site reduction, but that's for another day. It's probably past time to wrap this video up. On the outset of all this, 10th man said of me, he has a problem with celestial navigation, not me. But that's not true. I don't have a problem with either. As someone who has been sailing and using a sextant for 35 years, has written celestial navigation training software, and recently taught a seminar on the subject, I don't have a problem with celestial navigation. Also, 10th, believe it or not, I don't have a problem with you. I'm rooting for you. I want you to take that important next step beyond citations. Then, in the words of one of your own cited sources, a light bulb moment will occur and the deeper concepts emerge quite naturally. Because to those of us who actually have decades of experience with celestial navigation, the whole flat Earth sextant narrative is a bit like hearing someone who has no actual experience with cars claim there are little horses trapped under the hood, and no matter how much you encourage them to lift the hood and check for themselves, all they do is show you citations mentioning horsepower, followed by pictures of horses. Guys, it's way past time for you to look under the car's hood. Do some celestial navigation. I think you'll find it as fun as I do, and what you learn from it might surprise you.